Hey everyone, today I'm going to be showing you how to make an ion propulsion jet. What if there was a way to create thrust or lift without any moving parts and without high temperatures? Well, it is possible through ionic propulsion or ionic thrust. So first let me explain how I'm creating the wind that's going to generate the thrust. Now if you just have two electrodes that have the same geometry like this, the electric field on both sides of these is going to look about the same. If you look at the electric field lines, they're going to look about like this. So whether you're on this side or this side, the strength of the electric field is about the same. But that all changes if we put something pointy on one of the electrodes. So let's say I wrap some aluminum foil around this with a pointy end right here. Now, because of the point right here, the electric field is going to be more concentrated around the point than on this end. So now we kind of have an asymmetrical electric field going on. It's stronger on this side than on this side. And because it's really strong at the point right here, what it can do is it can actually rip some electrons off of the air molecules around it. And once it rips an electron off an air molecule, let's say we have a positive oxygen molecule, now it's going to want to move to the negative side, but on the way, because there's other air molecules around it, it's going to bump into those air molecules. And so it's going to get recoiled and bounce back the other way, but it's going to push some neutral molecules this way. So what that means is if we ionize some air molecules, it's going to create a generic neutral wind that gets pushed this way. Now the wind is not charged, it's neutral, but it's going to get propelled from the ions hitting them. And because the moving ions recoil and go back towards the positive, it's going to create some thrust on this electrode here. So it actually is going to push it a little bit because those positive ions are moving towards a positive electrode and that electric field will kind of push it a little bit. So the physics behind it is you're throwing neutral wind this way and it's pushing against the electrode this way. And this wind is so strong, I can actually blow out a candle with it. Let me show you. Okay, so I'm gonna light a candle right behind this electrode here, and we should see right when I turn on the voltage, it's going to generate a flow of air that's going to blow out the candle. Turn on the voltage. 3, 2, 1. And it blew it out. So this is pretty amazing. We're able to generate wind without any moving parts. So I showed you the movement of air that can be produced, but I haven't shown you how it can produce thrust yet. So now to show you the thrust that can be produced, instead of having a stationary point on the electrode, I'm going to have a point that can actually rotate, so it can actually move. So you can actually see the force on the pointy part pushing it. So to this electrode here, I'm just going to let this balance on this top here. So if there's any force on this tip here, it's going to cause it to spin in a circle. Okay, now let's turn on our voltage. 3, 2, 1. Okay, so it immediately spins in a circle. So the reason it's spinning in a circle is because it's creating this neutral wind this way, and that wind is causing the ions to get pushed back towards the positive electrode, which pushes it in a circle like that. And what's cool about this is you don't just need to have the point on the positive electrode, you can also put it on the negative one as well, and it creates the same effect. And what that means is if we can create a plane that has an onboard power supply that can generate this high voltage, all you need is the pointy end pointing away from the direction you want to go. It will create this neutral wind that moves this way and pushes the aircraft this way. But this is just to connect it to the power supply. There's nothing on the power supply that's going to make these spin. The spinning is going to come completely from the thrust at the back of the plane here. Okay, here we go. Let's turn on our power supply. 3, 2, 1. There it goes. Whoa. Knock it the other way. Now you may have heard of ionic thrusters before in relation to propulsion in space. So why don't we test out if you can actually use this method to propel something in a vacuum. So let's put our spinning propeller thing in the vacuum chamber and see if it can spin with no air. We're at a full atmosphere right now, so you can see that it's easily spinning in there. But let's turn on the vacuum and see what happens. 3, 2, 1. Still spinning at a half an atmosphere. We're at 0.25 atmospheres in there. Still going. It might be slowing down though. Okay, we're at 0.1 atmospheres now, so we're getting down to a pretty good vacuum in there, but there's still some air. Okay, so you can see it's still spinning in there. We're at a pretty good vacuum now, but it's still getting a little bit lower. You can't see on the gauge there, but this is definitely not spinning like it was at full atmosphere. Oh, it looks like it's stopping. I think it's stopping. It's trying to go. And it's stopped. Okay, so we're at a full vacuum now, and it's not able to propel itself forward using that ionic thrust. So you can see without air, it can't push itself forward because the thrust is actually coming from the ions hitting the neutral air. When there's no neutral air there, it can't push itself forward. But now, once we let the air back in, okay, let some air back in. And then it starts going again. Okay, so we're back at a full atmosphere. You can see that it's spinning like crazy in there. All right, so you can see that the ionic propulsion wasn't able to work in the vacuum. So why has NASA been looking at ion propulsion systems to work in space? Well, the reason it didn't work in our case here is because we were relying on the air around us to be moved and push the aircraft forward. So all you need to do to get an ion thruster to work in space is you need to bring the gas with you. There's no gas in space around you, so you supply the gas that's going to get propelled out the back. And the way it's going to get propelled is not through combustion like a typical rocket booster, but you're actually going to propel it using these electric forces and cause it to be ionized, create this neutral wind that gets ejected out the back, and it pushes the aircraft forward. Now what's really cool about these ion-propelled aircrafts is you can make them really small. In fact, researchers have been working on a drone that has no moving parts that uses this ionic propulsion to propel it through the air, and it's only the size of a coin. Now, I've seen some researchers and papers that suggest that ionic propulsion can actually get very efficient if you do it right. So maybe in the near future, we won't have planes that have to use jet fuel, but they can actually use stored electric power, convert it into electrical energy, and use ionic propulsion. So they have ion jets instead of combustion jets. Hey everyone, thanks for watching another episode of the Action Lab. I hope you enjoyed it. If you did, don't forget to subscribe if you haven't subscribed to my channel yet, and also hit the bell so that you can be notified when I release my latest video. And thanks for watching, and I'll see you next time.